So, good afternoon, everybody. There's been a lot of excitement about robots and robotics. So I'm going to talk about what is the role of robotics and how we can gain in robotics from AI. And also I will touch upon the issue of, which was also dealt with in some of the previous talks, about automation and whether automation will ever lead to a kind of boost in employment or to technology unemployment. But before I go into the meat of my talk, I prepared a 5-minute video in which I'm showing what has happened in the last 15 years in robotics. I worked on an exciting project on my life, which was the Springer Handbook of Robotics, which is considered a sort of the Bible in our community. And I did this with, I used to say, my brother, Usama Khatib, is professor of robotics at Stanford University. So I'm going to show you this video to get some excitement about the robots and how the robots are with us, within us, and among us. So this is a lot of excitement about robots in the last 15 years. But what is robotics? This is the modern definition of robotics. Robotics is usually defined as the intelligent connection of perception to action. So basically, we want to imitate the same skills as those of humans. Suppose that a human is thirsty and wants to get a glass of water, then it's like there's a stimulus that starts from the brain, and then there's some kind of sensing with visual and haptic feedback, and then eventually the person grabs the glass of water, and also there's a kind of intelligent command, and the command is actuated. So the three ingredients which make a robotic system are actuators, sensors, and control. It's like perception, motion, mobility, and intelligence. Now, there's a lot of interest between robotics and AI, up to the point that often these two terms are even used as synonyms. This is fine, but I want to provide a different viewing angle, a different reading key for what is AI, what is robotics, and what we can gain at the intersection of robotics with the AI. And I'm doing this exercise by this kind of paroxystic view of the human senses. This is known as the cortical homunculus. So this is an homunculus in which the importance of the senses of the humans are emphasized. So it's like the five main senses. And there is no surprise that the sense which also allows us to become more intelligently in contact with the world is the sense of touch. A child learns how to grasp an object at a young age, and it learns not only for its capabilities in the brain, but also because a child has a sort of embodied intelligence in the shape and in the articulation of the fingers of the hand. So definitely the physical intelligence is as important as the cognitive intelligence. And there is a famous paradox in the AI and robotic literature, and this is known as the Moravec's paradox. That you certainly remember that a computer beat the world champion of chess in a game, and that's fine, that's something that we can do with computers. It's less obvious that we can beat the skills or even of a one-year-old child, because besides intelligence, we have to deal with perception and with mobility. Now, when we speak about robotics, one of the science fiction writers which has inspired much of the work that has been done in the second half of last century is a science fiction writer, Isaac Asimov. And he established the famous three fundamental laws of robotics. So when we want to tackle what are the research challenges of AI, robotics, Asimov, and last but not least, I'm an engineer of engineering, we cannot leave decision to AI, which may have, this was discussed also brilliantly in the previous presentation, safety, moral and legal consequences, because we cannot ensure the outcome of applying some kind of fancy AI algorithm. So we have to use AI with robotics by adopting the proper technology. So the big challenge is that of brain and body. On one hand, we have the cognition capabilities as provided by AI. On the other hand, since the most developed sense is that of grasp in the hand, we have what is known in the field as manipulation. So this is a game between manipulation and cognition. And any progress in this respect will happen at the intersection, at the crossroads between artificial intelligence and robotics. So the big challenge is exactly found at the intersection of robotics with AI. And if we want to be able to comply with Moravec's paradox, that's much more difficult. So we are coming towards physical artificial intelligence, and we should be conscious that the blind use of AI in a deterministic way is potentially dangerous, because what is the difference between a computer and a robot? There is a physical action. And when we speak about physical action, most of the current research is tackling the problem of human-robot interaction. Of course, we can, as you saw in the nice video, We can have robots interacting social with persons, like those kids that were treated autism by using humanoid robot pets. That's fine. But the big challenge comes when we come to physical human-robot interaction. So I have a video and also I have a sound here, probably speaking to the... so when we handle this, can we get the sound? Okay, sure. Yeah. I usually show this video to my students in my first class of robot control. So this was the metaphor of modern times in 1930. I have to say that cinematography has inspired much of even the research work that was carried out, because now we're dealing about physical human-robot interaction. It's about 70, 80 years after the visionary movie by Charlie Chaplin. So there's a lot, and Estonia is the country of information technology, is one where the gradient is very steep. In my view, if we want to solve the challenges of physical artificial intelligence and physical human-robot interaction, we have to deal not only with information technology, but we have to deal with interaction technology. So there's a physical system, and we have to properly embed this physical system and all the challenges that are posed by these physical systems when we want to apply some AI. This was discussed previously, and you know that we have three big industrial revolutions, and we are now in the age of Industry 4.0, and it was already pointed out, we deal with cyber-physical systems. And the throughput of dealing with the cyber-physical system is a robot which is capable to interact, to share the same workspace with the human. And this is the cobot. So the cobot is a robot which allows the human to interact and to cooperate with robots. There is a biannual event which takes place every year in Munich. This is the Automatica Fair. Last June, on the even years. And I was there, and in the big hall, in the big pavilion of robots, I was really positively surprised by the fact that 90% of the robots that were displayed there, they were cobots, allowing physical human-robot interaction thanks to the use of lightweight material, but also thanks to the use of active control techniques like compliance, impedance, allowing the robot to feel the presence of the humans and to interact with humans in a safe and dependable way. And when we speak about robots replacing humans in some mansions, this was an issue which is discussed every year or often at the World Economic Forum in February in Davos. In 2016, there was a statement that because of robots, 5 million jobs will be lost, and robots are wrongly regarded as job killers. Let's take a look at, there's no sound on this video, so I can just let it and comment. So what are the robots, what are the jobs which are really at risk because of robots? Clearly, those kind of repetitive or alienating jobs in which the physical interaction is not an issue. So some jobs are safer than others. Let's take, for instance, autonomous truck drivers. Of course, we can have a truck which is autonomously driven along a motorway, but for legal reasons, the driver must always be on board to handle any kind of occurrences, any kind of situation. So this is one example in which the robot, the car, will coexist and will co-interact with the human. Another field of application, this was also dealt with by the previous speaker, is health. there's a lot of talk about using robotic technology for medicine, for surgery, for rehabilitation. And this is the case in which you have a kind of technology which is available, but still the decisional autonomy is always with the humans. So, the bottom line is that, of course, there will be some jobs which will be lost, but at the same time, there will be a turnover and some new jobs will be gained. And since I mentioned surgery, I currently direct the Interdepartmental Center for Advanced Robotics in Surgery at the University of Naples Federico II. And the dialogue with the surgeons, as well as with the patients, is that how much autonomy do we want? Right now, the level of autonomy is level 0. The commercial and clinical system, the Da Vinci system, which is used for robotic surgery, basically gives the surgeon the capability of operating behind the console with a high-dimensional and 3D vision, with a sense of immersion into the operating room and some filtering of the tremor of the surgeon. It doesn't do much more than this. For instance, it doesn't have any tactile perception. And tactile perception is important because even in minimally invasive surgery, in laparoscopy, not to speak about open surgery, the surgeon also feels the kind of tissue that has to operate. If the surgeon is doing some kind of suturing or anastomosis, it must feel the consistency of the tissue. So we want to increase the level of autonomy and move from the current status quo, which is non-autonomy, to robot assistance. For instance, the robot can suggest what are the best paths to do a sort of suturing? And this is an aid for a surgeon. A few months ago, I attended a keynote by the #1 robotic surgeon in the world, Pier Cristoforo Giulianotti, professor of robotic surgery at the University of Illinois in Chicago. And I was enchanted to see that with the Da Vinci system, he was able to even operate microsurgery at a micro scale, so from the millimeter to the micron. It's something that with the current technology, it's not available. It's like giving a Formula One car to a pilot like Hamilton or Vettel, or one of us to drive the car. Of course, the skilled driver will take the performance, will exploit the performance of the car much more, in a better way. So we want to go towards an autonomous system, but keep in mind that the final decision and the final autonomy is always with the human. And if we enlarge this kind of dialogue, we come to the so-called roboethics, which is not the ethics of robots, because robots as machines don't have ethics, but it's the ethics of those that design, that realize, and they use robots. And we are in a scenario in which we have to handle cohabitations of humans with robots. So the virtuous circle is that of life and robotics. And we, roboticists, foresee a future in which the robots are more social than solitary. So the question is not replacing jobs. Some jobs are replaced by robots, but it's a future in which the robots will actually cohabit with humans and will enhance the human work and life rather than replace them. And this will happen in our homes, in our hospitals, in our factories, in our farms and freeways. And I'm going to leave the stage and open the floor for discussion with a nice video which refers to one of our research projects on my team. The project is called RODIMAN. RODIMAN stands for Robotic Dynamic Manipulation. It's a project which was funded by the European Research Council, which is the most prestigious funding body that we have in Europe. So it's like less than 5% of the proposals get accepted. So I got an advanced grant funded by RODIMAN. And one night, I was in my lab working against the deadline with my team, and we wanted to find a sort of a demonstration of the concept of robot dynamic manipulation. So it's manipulation of objects in a non-prehensile way, without grasping, and manipulation of the formal objects. And being in Napoli, Napoli is the home of pizza, right? And pizza is actually, is now a UNESCO heritage, because that's where the pizza was invented. And I had the kind of crazy idea to propose as a demonstrator the various phases of preparing a pizza, because this would be a brilliant artifact of how complex and how much dexterity do we require to the robots to prepare a pizza. Of course, as a Napolitan, I will never eat a pizza prepared by a robot chef, but these things are happening, because after this, you know, we were, of course, this was a sort of mediatic expedient to attract attention towards robotics and towards Napoli. So this was, so I'll let you enjoy this video with sound, please. Here, and I'm open for questions and discussion, curiosities, whatever. Thanks.
Thank you very much. That was very interesting, getting the pizza guy. How many times did you actually record that pizza chef doing that to actually sort of get enough data?
Yeah, I mean, it's just like, you can get the data in real time. What perhaps, I don't know if it was clear from the video, it's not just imitation learning, because the robot has sensors, so it learns the best path from the pizza chef, other than coding, and then is a visual tracking. So in real time, there is an algorithm, is an intelligent AI algorithm, if you wish, that is capable of recognizing and tracking the deformable objects and to make corrections. So, I mean, just this could be like, one day I got a phone call from a guy from London. His name is Mark Olejnik, and he has a startup company which is called Molly Robotics. And he has involved Gordon Ramsay, the famous master chef, and the idea is to develop one day an app according to which you can order this dish of a Michelin star chef to be prepared to perfection, delivered to your home by a robotized kitchen, or maybe a drone, one of the Amazon, you know, just like. So the future is not so far, and why not having the creativity of the chef and have one of the sous chefs in the kitchen to be a robot? Because they are maniac. The master chefs are maniac, because the preparation of a dish must be perfect, and the plating of the dish must be to perfection. So, I mean, the future is now.
Very interesting. Have some questions out here in the audience. Okay, all good. No worries at all. 3, 2. There's always someone who comes on the 2. No? All good. 3, 2, 1. Sold. Thank you very much, sir.
Okay, thanks again.
You.
Thank you.
I'll take the
Sure.
clicker. Thank you.